Sourcing over 75 elements like gold, cobalt, and aluminum requires a complex global network, starting from the mine and ending in your pocket. We start with raw lithium and cobalt solutions. Through advanced chemical processes, we refine these elements. The ceramic shield front cover manufacturing process transforms raw silicates, culminating in the advanced ion exchange strengthening bath.
Using a solid block of aerospace-grade aluminum, CNC milling machines precisely transform the material into the intricate structural frame of the iPhone chassis.
Describe the electrochemical process of anodizing and dyeing the iPhone frame to achieve its specific metallic colors.
The robotic arm lifts the wafer carrier from the etching solution. The wafer is now coated and ready for the next stage of the surface mount technology process, where robots solder thousands of tiny components onto the iPhone's main logic board.
The vacuum deposition process layers organic light-emitting diodes onto the display substrate with atomic precision, creating the vibrant colors of the screen.
The digitizer integration process involves precisely aligning the capacitive touch sensors onto the OLED panel. Light patterns detail the assembly of the triple lens system, including the integration of voice coil motors for autofocus.
Explain the manufacturing and calibration of the LiDAR scanner for 3D depth sensing.
Stations. The assembly process precisely layers anodes, cathodes, and electrolytes. These components are carefully stacked and fold. The Taptic engine assembly begins with the linear resonant actuator, responsible for the precise haptic feedback in the iPhone.
Electromagnetic interference shielding is applied to internal chips to prevent signal disruption. Describe the kitting process, where various subassemblies are prepared for the main line. Detail how the finished chassis is loaded onto the automated assembly line using high-precision robotic arms.
The automated system precisely places the logic board into the frame. A second robotic arm then rapidly secures the dispensing of specialized waterproof adhesives along the perimeter of the chassis. The battery is secured using stretch-release adhesives or pull tabs inside the device. Detail the intricate process of connecting delicate ribbon cables from the screen and buttons to the logic board. Explain how automated electric screwdrivers apply exact torque to the hundreds of micro screws inside an iPhone. Describe the vacuum-sealed pressing process used to bond the display assembly to the frame for a watertight seal.
Detail the use of fiber lasers to weld with internal structural brackets for drop resistance.
The automated calibration aligns the TrueDepth camera system. The dot projector rapidly projects a precise grid of infrared dots.
Describe the first light test, where the device is powered on for the first time to check for basic boot functionality.
Detail the process of provisioning, where the latest version of iOS is installed onto the NAND flash storage.
Inside the anechoic chamber, we verify 5G, Wi-Fi, and Bluetooth signal strength. Robotics.
Describe the automated optical sensor test that adjusts the screen's true tone and color accuracy.
Detail the acoustic testing of the stereo speakers and microphones using high-frequency sound screens.
The automated system seals the device, initiating the pressure-based leak test. We pressurize the chamber to simulate submersion. Describe the high-resolution AI camera systems used to detect microscopic scratches or dings on the finish. Detail the human quality control checks performed to ensure the buttons and switches have the correct tactile feel.
Here we see the high-intensity laser rapidly etching the Apple logo, followed by regulatory symbols and the unique serial number directly onto the device's frame.
The robotic arm precisely applies the protective paper-based film over the iPhone screen, ensuring a perfect, bubble-free adhesion every time.
Our automated system efficiently folds and glues the eco-friendly, fiber-based material, rapidly forming retail-ready packaging.
Explain the automated insertion of the USB-C cable and documentation into the retail box.
Replacing plastic shrink wrap, these paper security tabs are applied by peeling the adhesive backing and smoothing firmly over the device's access points for a secure seal. Finished boxes are scanned, weighed, and then efficiently stacked onto pallets, ready for air freight shipping.
Defective components enter our closed-loop process, where Daisy the robot ensures maximum material recovery and reuse.